Here's the Windsor bowback, unbraced bowback in SketchUp, and it was created from in a book by Cassay, and I have a page out of that book and the photo scan out of that book. Here's the page showing the dimensions and the sizes and etc. You see a front view and a side view and a top view. That's perfect. The other thing that I want to show is how to figure out the drill angles for all these components. So these are compound angle objects, spindles, bow, legs, everything's at double angles. And the drawing doesn't show what that compound angle really is. And also you see all these sight lines here. Those are really effective and important when drilling the holes, because you only have to pay attention to one angle then when you drill. But we don't know that angle yet. And I'll show you how that gets calculated. So when I go back to the photo scan, I see the angle of the front leg here from the front view, 105 degrees. And then from the side view, it's 102 degrees. I can even check those here in this view. I can, but I'm thinking that I'm accepting his values here, 105 and 102. So what I can do first then is get that 105 degree angle shown. And the way I do that on this seat part here is go to the center of that hole and go down vertically on the blue axis, and then over on the, no, I want to go this way, red axis, and come back up here, click on that. Now I've got a face. It's a front view face, and I can pick the protractor and hold this green face here, click on that center part there, and I think I said 105, so I'm going to go 105 degrees. I'm just going to type that in, 105. There it is. And I will then draw that over that line and then delete this extra stuff here. So now I've got that 105 from the front view. I need 102 from the side. So I'm going to create a triangle just of any size here. Create that triangle, and that face faces the east and west, straight on. And I get my protractor, hold it on that axe, that face, and find the center right there. And I want to do a 102 degrees is what Cassay says, 102. There it is. And again, draw over that and get rid of stuff. Delete this right here. So now I've got the angle from the side view and the front view. And I need to intersect these two to get the compound angle. So I'm going to pull this out, the face of that, pull that out there, and then push this out there, and there's the real angle of the leg in that seam, in that intersection. So I'm going to draw a line there that represents that, and I can get rid of stuff. So I can get rid of that, get rid of that, get rid of all this, and that. Okay. So this line then represents the center line of the leg. And I want to get that angle, and I want to get a sight line out of that. And the way I do that is I'm gonna take the I'm gonna click on that so I get a length here of that thing all the way through the center out that way, and what I can do is bring a vertical line up here and connect to that line, and then connect again like that, and there is the sight line, this intersection right here. And I will draw that line, and where it intersects right there, intersection of seat. And then that sight line, I'd carry that sight line right over to the far side there and delete that little piece. Oops, can't do that. I'll do that. I gotta line up with that where it's pink. I want the pink, and I'll have to how that little piece there will get knocked off later. I'll just do it right like that. So now I've got a sight line, but I need the angle as well. And right here is the real angle to drill. So to find that angle, I get the protractor, hold it right there, and I go from here to there, and that's 108.9 degrees. Or you can take 90 off of that, and whatever that is. So that is the real angle to drill for that leg. That's how all these angles are sorted out for the spindles, back legs, and the bow. And it really makes a very nice way of knowing that when you drill that hole, it's going to be right on.